welcome to the second part of thermodynamics. We're going to talk a little bit about the second law in open systems. So we're going to predict the thermodynamically favored direction for a process based on delta G. We're also going to explain the thermodynamic role of enzymes, like how does that relate to the first and second laws? Where do enzymes come in? Because of course, that's the main point of biochemistry. Okay, so first off, in the last lecture I gave you this equation and we walked through a little bit about spontaneity, first law, second law, etc. Okay, so if you remember, when delta G equals 0, then that process is at equilibrium. So in order for that to be true, we plug that into this equation here. And we can rearrange. So the values of the temperature times the entropy has to equal to the value of the enthalpy in order for a process to be at equilibrium. Okay? But what about spontaneous processes? Under what conditions do those occur? So when we have a delta G value, when it's spontaneous, it has to be less than 0, because a negative value gives us more energy to use in the system. The value of delta H would then also have to be negative, less than 0, and the value of temperature, it doesn't really matter, because this temperature in this equation is in Kelvin and is always positive. So the value of delta S then would have to be positive, greater than 0, in order for this reaction to be spontaneous. Okay, there's another situation in which the reaction can also be spontaneous. So this is obviously 100% of the time when delta H is less than 0 and delta S is greater than 0, so the entropy is increasing, the enthalpy is decreasing, then we can expect a spontaneous reaction. However, if the value of this was extremely small compared to the value of this, then it wouldn't matter whether or not this is positive or negative. So we actually can have a positive enthalpy if it is small. This is always going to be positive, and delta S, as long as this expression is negative, greater than 0, and large, then the reaction can also be spontaneous. Okay, so what about non-spontaneous reactions? So when delta G is greater than 0, that means this would have to also be greater than 0, and T delta S would have to be less than 0. This would have to be negative, less than 0. So the entropy of the system would have to decrease, so we would have to get more ordered in order for this reaction to be non-spontaneous. And similarly, like above, you can think of examples where the delta H might be very large and positive, and this value might be very low, very small and negative. So it actually would decrease the contribution of this to the overall. Okay, so there you have it. You can predict the situations in which delta G will be at equilibrium, when it will be spontaneous, or when it will be non-spontaneous, based on this equation and the relative values of delta H and T delta S. So a question you might be having now is like, okay, reactions can be spontaneous or non-spontaneous with or without enzymes, and that's a big point here. that a lot of reactions can occur and do occur in cells without enzymes. So reactions can occur outside of the cell without the enzymes, just based on those thermodynamic properties. So why does the cell need enzymes? Okay, so remember, enzymes, these are chemical catalysts. So what chemical catalysts do in our free energy diagram, where we have the reactants performing a reaction and ending up as products, right? So in this particular example, we have the delta H would be right here, remember, and this energy right here is the energy of activation, or EA. So what a catalyst does is it actually lowers the activation energy. So instead of being so high, maybe now it's low. So here's the energy of activation if it's catalyzed. So all that means is it needs less energy in order for the reactants to become the products. And here we see a negative delta H. So this reaction would very likely be spontaneous. Okay, so what is the point of these enzymes? It's like the reaction can occur, and it does occur outside of cells, but why do we need enzymes inside of cells? And that's because of this idea that spontaneity is not the same as rapid. Just because something is spontaneous does not mean it happens quickly. The life processes in cells must occur very quickly, and this is the role of enzymes in thermodynamics in these cells, is that the enzymes allow these reactions to happen quicker, but without changing the energy of the reactants or the products. Those remain completely the same. Okay, here we've got energy, and here we've got reaction coordinate. Okay, so this is what you need to take away from this. We need enzymes because just because something is spontaneous doesn't mean it's rapid.